We can take the skills that we have learned thus far with SOHCAHTOA, trig functions, and use it to what we call solve a triangle. Now, when we're talking about solving a triangle, we're talking about finding all the missing measures, both side measures and angle measures, that we have in a triangle. And we can also maybe use some of our old friends like Pythagorean theorem or the Triangle Sum Theorem to help us along as well. So here we're looking at a triangle ABC where B is the right angle, and of course the hypotenuse is directly across from the right angle. And since we can also see that we know this side measure here, 20, we could either try to solve for angle C, but I'm going to try to solve for angle A. So I am looking at the opposite side and the hypotenuse. Opposite hypotenuse would go along with the sine function, or specifically the inverse sine function. So let's see, if I were then to say I want to find the sine of A, which is equal to the opposite side, 20, has a measurement of 20, over the hypotenuse, 37, and I want to find the angle A, I can then use the inverse sine function of 20 over 37, and we can then say that A is approximately equal to, and I'm not going to bore you by doing it on the calculator. I'm assuming by now you know how to do it. If not, you need to go back and look at some previous instructional videos. But it would be approximately, let's see, 33 degrees. Make sure you're in degree mode, not radian too, by the way, on your calculator. Now, to find angle C, well, I can just use, since we have now found angle A, and we know that angle B is 90 because that's given to us, I could use the Triangle Sum Theorem by saying that 180 degrees, triangle has a total degrees of 180, minus what we know, 90, minus 33, which we've just found, and that would leave us with angle C of approximately 57 degrees. That equals the measure of angle C. So we can say that's 57. Now I got one side measure. And you know, probably the most effective way to solve for that is going to be Pythagorean. So let's say then we can say that the 20 squared plus c squared, small c squared, don't get thrown by a squared plus b squared equals c squared, because our hypotenuse we know is 37 squared. So that c squared is equal to 37 squared minus 20 squared. And actually, this is how I would actually put it into the calculator. I mean, I could do 37 squared first, then subtract out 20 squared. What's 20 squared, of course, is not hard. It's 400. 37 squared is going to be a different number. And let's see, what is that? I really wouldn't even have to do that, but it's 969. So c squared is equal to 969. And then we could take the square root of both sides, so that c is equal to the square root of 969, where c, side c, we're talking about side c here, and we're going to round this to the nearest tenth. Our angle measures, we rounded to the nearest degree, would be 31.1. Well, Shazam, we have solved the triangle. You know, I've had so much fun doing that one, I want to do it again. Let's see if I can't do another one. All right, here I got a triangle. Now I know two of the angles. I got a 90-degree angle. I want to locate the hypotenuse. Of course, I'm dealing with SOHCAHTOA. Sine is the opposite over the hypotenuse. Cosine is the adjacent side over the hypotenuse. Tangent is the opposite over the adjacent. And, well, I could go ahead and find t real quick. Again, using the triangle angle sum theorem. So we got 180. Let's see. The measure, let's do it like this. The measure of angle t is equal to 180 minus 90 minus 23. Let's see what we got here. 180 minus 90 minus 23. And that would be 67. So the measure of angle T equals 67. 67. All right, now I've got two side measures I need to find. One of those is the hypotenuse, and one of those is the side opposite this 23-degree angle. Now, I want to kind of stick with what I have been given as the basis of how I'm going to compute this. So let's see, let's start then with the, well, tangent is opposite over adjacent. And I know the adjacent side to 23, to the theta of 23, which is 35, but I don't know the opposite, which is r. So let's work first with the tangent. So we could say that the tangent of 23 is equal to r over 35. And then if I multiply both sides by 35, then we would say that 35 times the tangent of 23 is going to equal approximately this side measure r. So let me put this in. 35 times the tangent of 23. And that would equal 14.856, or let's just say we'll round it to the nearest tenth. 14.9 is approximately the measure of side R. Now, once again, let me reemphasize, I want to kind of stick with what I know and what I've been given. And I've been given this angle of 23, and I've been given this adjacent side of 35, and I need to find the hypotenuse. And so let's see, adjacent hypotenuse. Well, by SOHCAHTOA, I must want to use the cosine function. And so then we could say, I'm going to go over here, maybe got a little bit more room, that the cosine of 23 is equal to 35 over, I don't like to use s because it looks like a 5. I'm going to say x over x. I'm going to substitute x for s. And let's multiply both sides by x. This would give us x times the cosine of 23 equals 35. And to isolate the x, we're going to divide by the cosine of 23. So 35 divided by the cosine of 23 should give us x, which we're saying is the hypotenuse. So 35 divided by the cosine of 23. And that's 38.02. So x, or s, is approximately equal to 38.0. And Shazam, we have solved a right triangle using SOHCAHTOA, using the inverse trig functions, using the triangle angle sum theorem, and we also used Pythagorean theorem, all within these two examples. It is a wonderful, wonderful day.